Now have Trevor Beardsmore. After 10 years at the survey, Trevor has the managing role of the New Energy Systems branch to coordinate our contribution to the state's green energy transformation, integrated battery industry development.
Well, good morning, everyone. Thank you for coming along. Thank you too to Warren for actually setting a lot of the scene for some of the data sets that I'm going to discuss today. And thank you too to the Minister and to Simon for also setting the scene. So I'm going to be talking about the critical minerals Geoscience exploration package. And again, as Warren has said, I'm really just the coordinator of that, and it is the combined work of the entire survey. Although in this case there were 7 or 8 key individuals who compiled the data for this. So we're working within the context of the state government's battery industry strategy and the new energy transition, and that's going to rely on technology to bring us to our aspiring net zero emissions world by 2050, but also still having a resilient economy. And that's going to depend on the resources to build those technologies. And that's largely going to be around critical minerals. So, having said that, I'll just give you a bit of background as to how we went about deciding on which data we would deliver to you, and then much of the talk will just be giving you a taster of the sort of information that we have. And I invite you to look at our poster out in the foyer out when you're having your lunch, and I'll be happy to discuss that with you. So Western Australia is very well endowed with minerals. We all know that. We're particularly well endowed with critical minerals as well. So this little periodic table here, the red boxes just indicate the 24 critical minerals that the federal government identified as being critical for Western Australian industry. And the other colours indicate whether we're actually mining them already or whether there is potential to extract those particular resources. They may already be present in materials we're mining. They may also represent new deposits. So moving right along. So here is the methodology. Now, because there were 24 critical minerals, we had a year to do it, we had to make a decision. So we picked particular critical minerals that might be of interest to people and particular mineral systems in which these critical minerals might be found. And then we thought about what sort of data might be useful for the explorer that might indicate the presence of the mineral systems that might contain these. So there's the list there. I invite you to actually have a look at the abstract and the poster that has that information there. The idea really was to provide what we regard as a sufficiently comprehensive database of information to get people started, but more importantly just to show you what sort of information you can get from our databases and how to do it as well. We're the ones who built the databases. We know how difficult they are to navigate in some cases, so we're helping you out there. So we produced a whole range of different map classes there on the right-hand side, known occurrences, prospective rock types, etc. So really now I'll just go through and illustrate the sorts of things that we have produced for you. So we will start with mineral occurrences. Now you're all familiar with our Mindex database. It's a lovely map with lots of colour on it. When it comes up, there it is. And each of those colours represents a particular commodity. You'll also know from our raw Mindex database that it doesn't just contain mineral occurrences, it contains a lot of other stuff like infrastructure. So we first of all produced a Mindex database that only has occurrences. We've stripped out the other material, and that then allows us to start searching for particular commodities. And we decided to produce maps for 16 different commodities or commodity groups. And some examples will eventually show up, lithium being one of them, and here it is. So we can now provide individual maps showing where lithium is being mined or where there's a major deposit, where there's a resource defined, but then also other occurrences to help you zero in. Largely classified by site type, but we also have the capacity to search by target commodity group, element associations, or by what we call our commodity group. I urge you to read the abstract to understand what the difference is there. So that's occurrences, and this was also done in collaboration with Warren's group as well. So we produced a suite of these sorts of maps. Here we go. Geology. That's what we're really about. This is our interpreted bedrock geology map, except it's a slightly different one, where we've actually inserted the 1 to 100,000 scale interpreted bedrock geology with the 500,000 scale interpreted bedrock geology to provide the best possible resolution of interpreted geology. Having done that, we can then start querying for particular rock units that might be prospective for particular critical minerals. So again, these polygons are all embedded with information and allow you to query it. And we can produce examples like this one, which shows all the rock units that are either majority comprised of or contain minor components of mafic igneous rocks. Specifically, if you're looking for instance, nickel, copper, platinoids, cobalt, you're looking for mafic intrusions. So there's a whole swag of these sorts of layers in the critical minerals database, all GIS registered. You can import them into the GIS package of your choice. And we've produced layers for a range of other types of prospective rocks. We've also tapped into our WAROX database. So this is our database of our 130 years of geological observation, and we can query that for particular rock types as well. And the example I've shown here is for all the occurrences of pegmatites that are in our WAROX database. We've also got locations for kimberlites, lamproites, carbonatites, those sorts of alkaline intrusions that might contain rare earths, for instance, and then also a range of other rock types. And again, mafic igneous intrusions as well. It's the first time we've attempted to use our WAROX database to produce product that might be used for mineral prospectivity or targeting studies. Moving right along, and outcrop maps. Now the IBG only shows the largest units, but there are a lot of geological units, geological rock types that won't show up at that scale, but which are significant for exploring for critical minerals. Pegmatites might be one of them, quartz veins, and again, the small alkaline igneous intrusions. So our group went through all our mapping and digitised those small geological units and produced them as GIS layers. So you have quartz veins, you have pegmatites, and you have those alkaline intrusions. So you now know where they are in the state without having to pore over a digital scan of our maps. So we also looked at mineral fertility. So what sorts of minerals might be indicative of the critical mineral system that you're looking for. So they might be minerals indicative of the prospective rock types, which are listed there. They might be the actual ore minerals themselves, or they might be the minerals that could be associated with alteration associated with those sorts of mineralising systems. And that includes those minerals that might represent the metamorphosed equivalents, because there are probably mineral systems out there that have been through the metamorphic ringer after having been formed. And again, we have a whole range of layers there, again extracted from our WAROX database observations. Here's the big one. Warren's already mentioned it. Now we have our standard geochemical data sets, our WAChem data set. You can also tap into the Geoscience Australia data set as well, and the CRC Leam laterite geochemistry data set. But as Warren said, we've now collected together all the exploration geochemical data and harmonised it with our other data so that there is a single column for every particular analyte and consistent units of concentration. Again, Warren's already mentioned the caveats that go with that, but at least what it does is it significantly expands the potential geochemical coverage of the state. We've gone from about 70,000 data points to something around 11 million. And they're in a range of different categories there, being soils, stream sediments, rock chips, or shallow drilling or auger. All there to be used, which then allows you to do things like this. And here's just an example where we're looking at manganese oxide in those data sets, and instantly you can start seeing highlights of areas there where there's comparatively elevated manganese. Now these are layers we provided you with. We also provide you with the underlying data sets, so you don't have to just use our layers. You can do queries for whatever you like as well. So the little table on the left there, I don't expect you to read it, but they're just other potential chemical indicators of fertile rocks or mineral systems that might contain critical minerals. Okay, moving along. Geochemical fertility also includes hydrochemistry. CSIRO has produced or compiled a very large set of hydrochemical data from wells and bores. We've gathered 3 separate data sets together, combined them, harmonised them and provided them back to you. So this is another case where we're borrowing other people's data sets and packaging them with our critical minerals data set to make that overall package. And then you can start doing searches for the analyte of your choice. There are 95 analytes in this database. We've produced maps for 31 of these, obviously oriented around critical minerals. And that data can be used either for brine-hosted mineralisation, as you may know from the potash industry, or even for determining prospectivity for bedrock-hosted mineralisation as well. And we've, again, borrowed the paleochannel and lake layers from Geoscience Australia, and the Bureau of Meteorology, we've borrowed their climate indicator maps, rainfall, evapotranspiration and evaporation time averaged. So if you're interested in exploring for those evaporite or brine-related commodities, these data sets may be of use to you. And where do you get it? So this is getting to the end of the presentation here. The Data and Software Centre should be the first port of call. All the data layers are packaged up in the critical minerals exploration package within that, in GDA 94 and in GDA 2020. If you wish, you can get some of the layers on the Mineral Systems Atlas for instance, the orthomagmatic vanadium systems or the rare metal pegmatite systems, or you can just go to the front desk and pick up a USB with all this material on it for free. So I urge you to do that. And I believe that is the end. So at lunchtime, come and speak with me about the poster or any other aspect of critical minerals. I'm happy to talk to you. But yes, burrow into it and let us know what you think. Thank you very much.